Business Cal, topic 2.3, 6, 11, 17, and 25. Okay, we want to find the instantaneous rate of change for this using our H algebraic notation, algebraic procedure in H's. So this will be f of -2, f prime of -2, will equal f of -2 plus h minus f of -2 all over h. Oh, sorry, and this will be a limit as h goes to 0. Okay, that'll give us our instantaneous. Without this, all this will be is a average rate of change. Okay, so let's write this as limit as h approaches 0. Everywhere I see an x, I'm going to put a -2 plus h. So this is 2, -2 plus h squared plus -2 plus h. Then a negative here, and then a parenthesis, and all this is for the f of -2. So everywhere I see an x, I'm going to put a -2. So 2, -2 squared plus -2. And that's all over h. All right, next, I'm going to simplify this. First, I'm going to expand this using binomial expansion. So we have 2 parentheses 4 minus 4h plus h squared. Okay, this we'll just keep in the parentheses. And this right here will simplify the inside here. We'll have, let's see, -2 squared is 4. 4 times 2 is 8 minus 2. Alright, then I'm going to distribute this 2 here and get rid of all and this negative. So we'll get 8 minus 8h plus 2h squared. This will be -2 plus h, and this will be -8 plus 2 all over h. Well, the 8's cancel and the 2's cancel. And what we're left with is the limit as h approaches 0, we'll have -8h plus 2h squared. I'm sorry, plus that right there would be -7. -7h. Sorry, didn't add those 2 right there. And that's all over h. Then we can factor out the h in the numerator, leaving behind -7 plus 2h all over h. And those h's can cancel, and we'll end up with the limit as h approaches 0 of -7 plus 2h. So this implies when we make h 0, this implies -2. The derivative of -2 is -7 because this h becomes 0. Okay, once again, we want to know the derivative at a of 2, so f of -2. And this will be the limit as h approaches 0. The function will be f of -2 plus h minus f of h. Or f of -2, sorry, all over h. And this ends up being the limit as h approaches 0. Everywhere we see an x, I'm going to put a -2 plus h, so 3, -2 plus h minus 4, then a minus sign, and then from here parentheses. So everywhere I see an x, I'm going to put a -2 now. So this will be 3 parentheses -2 minus 4 all over h. Now a little distributing will give me a -6 plus 3h minus 4. This will be a -6, so what we'll get is a +6 and a +4 for those two when we distribute that negative. The 6's will cancel and the 4's will cancel, and we'll be left with the limit as h goes to 0 of 3h over h. Well, the h's cancel, and we're left with 3. Okay, number 11. Okay, once again, we want this function f of 1, derivative f of 1, will be f of 1 plus h minus f of 1 all over h. And we want the limit of that as h approaches 0. Oops, sorry, it's way too high. Alright, let's start that again. Okay, so we want the derivative f of 1 as the limit of h approaches 0. And we want to have f of 1 plus h minus f of 1 all over h. Okay, so this will be the limit as h goes to 0, and everywhere we said x, we're going to put a 1 plus h. So this will, instead of negative 1 over x, this will be negative 1 over 1 plus h. The minus sign. And this means everywhere we see an x, we're going to put a 1. So instead of a negative 1 over x, it's going to be a negative 1 over 1. That's all over h. Alright, let's simplify this. This will simplify down, well, this will remain negative 1 over 1 plus h. This is double negative, so we'll have a positive 1. Now from here, I'm going to multiply the numerator and the denominator by the common denominator, which is a 1 plus h. As a result, we're going to get, let's see, this times this. 1 plus h divided by 1 plus h times negative 1 is negative 1. 1 plus h times 1 is going to be 1 plus h. And 1 plus h times h is going to be h times 1 plus h. Okay, and the 1's will cancel, and what we'll have is the limit as h goes to 0 of h all over h times 1 plus h. These h's cancel, and we'll have limit as h goes to 0 of 1 over 1 plus h. And when our h, oops, should be a 1, when our h becomes 0, this ends up being 1 altogether. Okay, next, lastly, we want to do this in general, so we'll begin with the same function. Limit, but we're going to use x instead of 1. Limit as h goes to 0. Our function is x plus h minus f of x all over h. So we're using x's instead of the 1 or any other number. Alright, so from here we have the limit as h goes to 0. Everywhere we see an x, we're going to put an x plus h. So negative 1 over x plus h. Here, everywhere we see an x, we'll keep it x. So this will remain, parentheses, negative 1 over x all over h. Now from here, we have double negatives, so that'll cancel, become positive. So we're going to simplify this one by one step by one step. So plus 1 over x all over h. Next, we'll multiply this by the common denominator, which will be x times x plus h. And also this by x times x plus h. Now the reason why I'm choosing this as a denominator, because the denominator here is x plus h, the denominator here is x, but the denominator here is actually a 1. So x plus h, 1, and x creates an LCD of x plus h. Now let's distribute here. So we'll get the limit as h goes to 0. The LCD divided by x plus h times negative 1 is negative x. The LCD divided by x times 1 leaves x plus h. And the x plus h, LCD times h, is h times x plus h. Okay. These two cancel, leaving us the limit of h over h times x plus h. And we end up with another cancellation, these two. and that leads us to the limit as h goes to 0 of 1 over x plus h. Now when we make our h 0, this will be 1 over x times x plus 0. X plus 0 is x, so this is x times x, which ends up giving us x squared. So, sorry about that, which ends up giving us x squared. So this is the derivative f of x.